Hello and welcome to everyone to my presentation. I am Vikas Prasad Yadav. My roll number is KAN 077 BCE 018. This is my video presentation for maths. Here we will discuss about three questions. Question number one, approach to civil engineering. Question number two, parabola, and question number three, ellipse. First question, which is related to approach to civil engineering. Let's read the question first. A circular column of variable section supports a dead load P. The means compressive stress of any horizontal section has constant value of material construction weight W per unit volume. If the column has a radius x and depth y from the top, prove that pi fx square is equals to p times e to the power wy by f. So coming to the solution, let x be the radius of the section of the column at depth y from the top. Consider the equilibrium of elementary slice of the column thickness del y. It is acted by compressive forces R. F. We have three forces. First force, let's call it F1, which is equals to pi x square times F, and second force is pi times x plus del x whole square times F, and its own weight F3 is pi x square del y times weight. So once looked at the picture, here clearly mention everything. This is load P, we have dead load P, and here we have del x F. So moving to the next slide, let's for the equilibrium of the element we can have the following equation, which is equals to f1 minus f2 plus f3 is equals to 0. Now putting the value of respective values, we can write pi x square times f minus pi times x plus del x whole square times f plus pi x square del y plus w is equals to 0. Which on further solving, we get pi x square times f minus pi x square f minus 2x f del x minus del x whole square times f plus pi x square del y times w, which is equals to 0. Now solving it, we will obtain minus 2x f del x minus del x whole square times f plus x square del y w is equals to 0. Now we will divide this equation by del x on both sides, and taking limit del x tends to 0, we get minus 2 x f minus limit del x tends to 0, del x times f plus x square limit del x tends to 0 times del y by del x times w is equals to 0, which now it becomes minus 2xf minus 0 plus x square dy by dx w is equals to 0. This is some simply differential equation. Separating these variables, we get w by f time dy is equals to 2x dx. Integrating both sides, we will get w by f y is equals to log x square minus log c is equals to log x square by c. Now we will get x square by c is equals to e upon w by y divided by f. Now we will get the value of x uh, which is now which is x square is equals to c times e to the power w by f w into y by f, where f uh, uh, f we assume r as the radius of the top section, so that when y is equals to 0 x becomes r. uh, from equation 1 we have r is equals to c into e to the power 0, and we know that the e to the power 0 is equals to 1. So now r square is equals becomes c. In addition, we use the fact that when y is equals to 0, the compressive forces is dead load p. We have p is equals to pi r square f. P is equals to uh, pi cf. Therefore c is equals to p by pi f. From equation 1 we have x square is equals to p by pi f times e to the power w y divided by f, which further on solving we get pi f x square is equals to p into e w x divided by f, hence proved. Now moving on to the next question, question number 2. We have find the axis tangent at the parabola equation and length of latus rectum and coordinate of vertex and focus of parabola given below. So the given equation of parabola is 9x square minus 24x plus 16y square minus 50x minus 100y plus 25 is equals to 0. uh, uh, Now we have to make it a perfect square. So for that we can write 3x square whole square minus 2 times 3x into 4y plus 4y whole square minus 50x minus 100y plus 25 is equals to 0. So we reach to the place where we want to, that is 3x minus 4y whole square, which is a perfect square, minus 50x minus 100y plus 25 is equals to 0. Now introducing for further solution we have to introduce a term lambda inside the bracket. So now we will get 3x minus 4y plus lambda whole square. Again, to balance this we have to write minus lambda square plus 8 lambda y minus 6 lambda x minus 50x minus 100y plus 25 is equals to 0, which on further solution we will get 3x square minus 4y plus lambda का whole square is equals to 6 lambda x plus 50x plus 100y minus 8 lambda x 8 lambda y plus lambda minus 25. Now 3x minus 4y plus lambda is equals to 0. Let's take x common. Then we will get 6 lambda plus 50 times x. Again let's take y common in these two terms. So we will get 100 minus 8 lambda times y plus lambda square minus 25. Again we should write 3x minus 4y plus lambda whole square is equals to uh, uh, now let's take 2 common among these both uh, remaining parts. So we can write 2 times 3 lambda plus 25 times x plus 2 times of 50 minus 4 lambda whole times y plus lambda square minus 25, which is our equation 1. Now we have to choose lambda in such a way that 3x minus 4y plus lambda must be equal to 0, which is our equation 2. Then the equation 1 reduces to 2 times 3 lambda plus 25 x plus 2 times 50 minus 4 lambda times y plus lambda square minus 225 is equals to 0, which is our equation 3. Now let's move further. Slope of equation 2 is m1. We can write minus a by b, which is from the equation we will get minus 3 by minus 4, which becomes 3 by 4. uh, Now slope of equation 3 is m2 is equals to minus a by b, which is minus 2 times 3 lambda plus 25 by 2 times 50 minus 4 lambda. Here 2 and 2 get cancelled, then the remaining parts will be minus 3 lambda plus 25 divided by 50 minus 4 lambda. Now we know that if equation 2 is perpendicular to equation 3, we have a formula that is m1 into m2 is equals to minus 1. So we have both the values. Putting the values of m1 and m2, we get minus 1. Solving this, we get the value of lambda, which is equals to 5. Now substituting the value of lambda 5 in equation 1, we get uh, 3x square minus 4y plus lambda whole square is equals to 2 times 3 lambda plus 25 multiplied by x plus 2 times 50 minus 4 lambda multiplied by y plus lambda square minus 225. Then it becomes 2x 3x minus 4 y plus 5 whole square plus 2 times 3 into 5 plus 25 into x plus 2 into 50 minus 4 into 5 plus y plus 5 whole square minus 25. So after putting the value of lambda, our equation turns to 3x minus 4y plus 5 whole square plus is equals to 80x plus 60y minus 200. Then it Now we have to reduce this equation in the form of y square is equals to 4ax. So we can write 3x minus 4y plus 5 divided by root under 4 square plus 3 square multiplied by root under 3x square plus minus 4 whole square, now whole square, uh, 20, which becomes 20 into 4x minus 3x minus 10 divided by root under 4 square plus 3 square times root under 4 square plus 3 square. Solving this, we get 3x minus 4y plus 5 divided by 5 whole square is equals to 4 times 4x minus 3y minus 2x. Now look at this, we got what we want. Y, which we can write that y square is equals to 4 times ax, which is in the standard form of parabola, that is y square is equals to 4x. So comparing it with y square is equals to 4x, we get y is equals to 3x minus 4y plus 5 divided by 5, and 4a is equals to 4, that is a is equals to 1, and also we get x value is equals to 4x minus 3 minus, okay, 4x minus 3y minus 10 divided by 5. Now axis of parabola is equals to, we have lx minus my plus n is equals to 0, or from equation we have 3x minus 4y plus 5 is equals to 0. Also tangent at vertex, we have mx plus ly plus q is equals to 0, or from question 4x plus 3y minus 10 is equals to 0. Again we have equation of latus rectum, that is x is equals to a. So we can write 4x minus 3y minus 10 by 5 is equals to 1. Solving this, we get 4x minus 3y minus 15 is equals to 0. Again we have length of latus rectum, that is 1 by root under L square plus M square, which in solving and putting value we get 1 by 5. Again we have to find coordinate of vertex, that is a coordinate of vertex is the point of intersection of axis and tangent at a vertex. So solving one equation 1 and 2 to get the coordinate of vertex uh, 1 2, that is uh, we get 1 and 2. So coordinate of focus is the point of intersection of axis and equation of latus rectum. So solving this, the coordinate of focus will be 9 by 3 and 13 by 5. So let's move to our next question, that is ellipse. uh, so uh, so questions from ellipse is uh, so that the conic represented by the equation given below is an ellipse. Also find its center. uh, equation refer to the center, equation of axis and length of axis, eccentricity, length of latus rectum, foci, directrix, uh, directives. So we have to find this many things. So let's write the equation, that is 5x square plus 6xy plus 5y square plus 12x plus 4y minus 4 is equals to 0. The let's solve this. The given equation of the conic is 5x square plus 6xy plus 5y square plus 12x plus 4y minus 4 is equals to 0. Let's call it equation 1. Now comparing this equation with the standard equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. We get a is equals to 5, b is equals to 5, h is equals to 3, g is equals to 6, f is equals to 2, and c is equals to minus 4. Now we have to prove that the given conic represents an ellipse, and to be an ellipse the given equation should satisfy two conditions. Let's go for first condition, that is determinant must not be equals to 0. So finding its determinant, uh, we get minus 96, which is not equals to 0, which means it satisfies the first condition. Now let's go for second condition, which is ab minus h square must be greater than equals to 0. So putting value and solving, we get 16, which is greater than equals greater than 0. uh, then both the condition is satisfied, since we can conclude that the given conic represents an ellipse. uh, Center. To find center, we have to differentiate the given equation with respect to x first, and then with respect to y. So differentiating with respect to x, we get 10x plus 6y minus 12 is equal plus 12 is equals to 0, which is equation second. Again differentiating with respect to y, we get 6x plus 10y plus 4 is equals to 0, which is equation 3. Solving equation second and 3, we get center minus 3 by 2 and 1 by 2. Let it be alpha and beta. Let's call the center alpha and beta. Equation refer to center. uh, Shifting the origin to minus 2 3 by 2 and 1 by 2, we have small x is equals to capital X minus 3 by 2, and small y is equals to capital Y plus 1 by 2. Here we get capital X is equals to small x plus 3 by 2 and capital Y is equals to y minus 1 by 2. Then new equation is ax square plus 2hxy plus by square is equals to uh, del by h square minus ab. Now putting the value, we get 5x square plus 6xy plus 5y square is equals to minus 192 by 9 minus 25. Then on further solution, we get 5x square plus 6xy plus 5y square plus 12. Now we get 5 by 12 x square plus 1 by 12 1 by 2 xy plus 5 by 12 y square is equals to 1, which is the required equation referred to the center. Now let's find length of axis. Comparing equation 4 with ax square minus 2hxy plus by square is equals to 1, we get a is equals to 5 by 12, h is equals to 1 by 4, b is equals to 5 by 12. Now we have to write this equation: 1 by r square r to the power 4 minus 1 by r square times a plus b plus a plus b, in putting it into the bracket, plus ab minus h square is equals to 0, which on further solving we get 1 by 4 minus 1 by r into 5 by 6 plus 1 by 9 is equals to 0. Now solving for r, we get r1 is equals to 206 and r2 is equals to 203 by 2. So length of semi major axis is root under 6 and length of semi major minor axis is root under 3 by 6. We must know that length of semi major axis is always greater than length of semi minor axis. The equation of axis: the equation of minor axis is a minus 1 by r1 square uh, uh, times x plus hy is equals to 0, or x plus y is equals to 0. Now replacing the equation x and y, we get x plus y plus 1 is equals to 0. Similarly, equation of minor axis is a minus r2 का whole square times x plus hy is equals to 0. We get y minus x is equals to 0. Now replacing the value of x and y, we get y minus x by is equals to 2. Now let's find eccentricity. We have r2 whole square is equals to r1 whole square times 1 by 1 minus e square. Solving this and putting value, we get e is equals to root under 3 by 2. Now let's find length of lattice rectum. For this we have to write 2 times r2 whole square by r1. Now further solving this, we get the value of lattice rectum is root under 3 by 2. And now the equation of major axis is x plus y plus 1, so its slope is minus 1, that is tan theta is equals to minus 1. So we can put this by Pythagoras theorem. Sin theta is equals to minus 1 by root under 2 and cos theta is equals to 1 by root 2. So let's find foci. That is, foci is alpha plus minus e times r1 cos theta, comma b plus minus e times r1 sin theta. Now putting the value and solving, we get foci is equals to 0 comma minus 1 and 3 minus 3 comma 2. Equation of derivatives is x minus alpha times cos theta plus y minus beta times sin theta is equals to plus minus r1 by e, which on solving we get the equation of derivatives is x plus y plus 1 is equals to 4 and x minus y is equals to 3. So here we discussed about 3 questions related to approach to engineering, parabola and ellipse. So thank you for listening me, and that's all. Thanks a lot.